Now, I expect that you understand perfectly well almost everything that's been said here. Whether you understand it the way it's been phrased could be a different question, so let me clarify a few things. However, before you watch anything that I'm doing, and I say this often, you should by all means have pondered what these questions mean and how they're related to the constructions we've looked at. So, okay, any length factor, 1 over 2 to the n, is constructible. So here's the length, right? Okay, so let's see. I can geometrically, subdivide this, and here's the bisector. And then I can subdivide that segment and get perpendicular bisector, mark this point. And then I can subdivide that, and I get this. Now, I'm not going to keep writing the sloppy attempts at depicting the arcs. Those faint lines are just there for reference. I can continue this as long as I wish, and eventually I get down to the point where I can't distinguish the distance between the points from the size at which I had to depict that dot so that you could see it using a fairly crude marking instrument. But theoretically, we have a point here and a point here. You're never going to get to this point. So if I want to specify any degree of smallness, okay, let's say I want the distance to be no more than the length of this line segment. Well, I divide it once, and my distance here is bigger than this. I divide it again, my distance is still bigger than this. I divide it again, still clearly bigger. I divide it again, it's still bigger, but it's starting to look like we're getting close. And if I divide it once more, then it's very plausible that the distance between my divisions is bigger than this small distance. And if it isn't, I divide it once more, and I'm sure it will be. Now, I can make that distance microscopic, okay? If I keep subdividing, am I going to eventually get to that distance? I can make it smaller than an atom. Now, I can't actually construct that physically out here in the real world, but theoretically, if we had infinite precision available to us, could that be constructed? So the question is this statement true? Any length factor 1 over 2 to the n is constructible. Now, what's 1 over 2 to the n have to do with this? Well, right here we have length 1/2. Here we have length 1/4. Half of that is 1/8. Half of that is 1/16, 1/32, 1/64, etc. But, okay, 1/2 is 1 over 2 to the 1. 1/4 is 1 over 2 squared. 1/8 is 1 over 2 cubed. All for reasons that you should understand very well. If we take 1/2 of 1/2, we have 1 over 2 squared. Now, if you understand fractions, which I think most people do, not as well as I might hope, but people right now seem to be pretty competent with fractions at the sophomore level. Students who've had Algebra 1 and geometry appear to have reasonable competence with fractions. Okay, and some very good. So this shouldn't be an impediment. If we do 1/2 of 1 over 2 squared, I get 1 over 2 times 2 squared. 2 times 2 squared is 2 cubed, etc. Okay, then 1 over 2 to the n can be as small as we wish. Then m times 1 over 2 to the n is constructible. Well, once we have n, and let's just say n is 1/16. Okay, so right here would be 1 over 2 to the 4th, which is 1/16. That would be the length of a segment from the left end to this one. Then I could do just as we do with rulers that measure in inches. I can divide each inch into half, and then I can take half of that and get a quarter, and add that to this and get 3/4. Okay, so here is 1/2. Here is 1/2 squared, which is 1/4. And here is 3 times 1/2 squared. Okay, so there's an m equal 3, n equal 2. M times 1/2 to the n is this, which is 3/4. And then I can divide this into eighths and get all multiples of 1/8. Then I can divide into 16ths and get all the multiples of 1/16. Now, if I want to go beyond this, well, I can just do the same thing. I can just repeat this interval over here, double it, and have the same markings and so forth. Again, look at any tape measure, and you'll see that done. Now, the tape measures often do go down to the 32nd of an inch, and some even to the 64th of an inch. Beyond that, our eyes have trouble resolving the distances. So really what I'm saying here is that we could make a ruler in standard foot and inch units that measures 1/2, that measures in intervals of length 1/2 to the n for any n, multiplied by L, and where L would, in this case, maybe be an inch. Anyhow, you should get the idea. Ponder a tape measure or a ruler marked in inches. Then, no matter by what factor we wish to change our length, we can come as close as we wish with some factor of the form m/2 to the n. So let's say we wanted to change our length by a factor of 87 hundredths, 0.87. Okay? Now, 87 hundredths is not constructible. But if we have our lengths divided into 1/2 to the 7th, 128ths, then the distance between these marks will always be 1/128th. And if we locate 87 hundredths, we can locate 87 hundredths, we know which mark would be to the left and which mark would be to the right, at least if we're competent with simple fraction calculations, which again, I'm finding that people are. We can locate that on that ruler, and we know, or we can determine between which two markings that will be. So we're going to know that if we use either of those markings, either of those m/2 to the n fractions, we're going to be within 1/100th or 1/128th in this case of the correct position. Okay, so we can refine this as much as we want so that we can actually geometrically, in a theoretical sense, we can geometrically construct any factor that's as close as we desire to being accurate. Even if we can't get it completely accurate, we can get as close as we desire. So if we wanted to do factor pi, okay, well, we got a number line here. And I guess I started off with 1. Let's fix that. 0, 1, 2, 3, 4. And presumably we've specified our distance from 0 to 1, and then we've marked off the same distance here, same distance here, same distance here. I didn't do a very good job of that, but we could do it. Okay, so we want to locate pi on this thing. Well, pi turns out to be one of those numbers that you're never going to construct. But we can subdivide a bunch of times. And of course, we can then do the same subdivision on this interval here. Okay, there we've divided it into 16ths, and pi is between 3 and 2/16 and 3 and 3/16. So we can construct anything in this interval will be within 1/16 of pi. So we can construct a segment of length pi, give or take 1/16. Now, if we want to go to 1/1,000,000th, well, we do this subdivision 20 times and we're within a millionth. Okay, just figure out which fraction is within a millionth, between which two fractions, with denominator 1 over, with the denominator 2 to the 20th, n equals 20. We can do that. So again, ponder this, make sure you understand this, and write your reasoning on these statements out. Don't just repeat what I said. Think through it yourself and say it the way you would say it.